Hi, fellow geochemists and geochemistry enthusiasts. Welcome to GeoChemISTea, the only podcast for people who love geochemistry with a side of tea. Our mission is to inspire future geochemists and to introduce our listeners to niche geochemistry topics. I'm your host, Sam Scher, and this month we're talking with Oscar Benavente about the dynamic mapping of water bodies to monitor mine drainage related processes with satellite imagery. Oscar Benavente is a geochemist at SRK Consulting. Oscar, welcome to GeoChemistry.
Sam, thank you very much for hosting me. This is going to be my first interview as a geochemist. I have been interviewed before, but in other situation, music or even Magic the Gathering as well. I'm a very nerdy guy. but but
I
as a
love that.
geochem, no, actually no, it is the second one. The first one was in Comore Island, some islands that are in Africa, in
Yeah.
between Madagascar and continental Africa. I was doing some geothermal exploration there, and I was interviewed as well.
That sounds fancy.
Yeah, that sounds fancy. We can talk about my whole geochem
I
journey.
cannot wait.
Yeah,
I cannot wait. And look, you're the one that got geochemistry on YouTube, so you're the one that's driving us to be more cutting edge and fancy. So I can't wait
yeah,
to hear
no,
about all of
definitely.
your experience.
Definitely. As I told you when we met, I'm not a huge fan of Spotify, but I paid my YouTube premium subscription and I see most of my podcasts and TV shows and radio shows on YouTube. So it is great that you have posted all of the previous
Yeah, I'll have to look for your
interviews
comments and
there.
your likes. Then I know that you're listening.
Yeah. Okay. Yeah. No, I'm very bad. I'm very bad doing that, but I'm gonna try to do it, especially with my interview.
Yeah, you got to
I'm
boost the
gonna
ratings.
exactly.
If I could get so many people that enjoy the YouTube channel, I think that's our first step towards actually becoming wealthy because I could be like one of those YouTube kids that opens boxes or something like that. Geochemistry. Let's open a package. Poof. I don't know.
as
Anyway.
soon as soon as you don't receive any radionuclear gift, it's okay. Remember that you live in Washington, and
Oh, yeah,
maybe the
yeah.
authorities won't like to you receiving some radionuclear stuff.
Yeah, that could be it. So listeners, send me gifts. We could do an open and gift day
Yeah.
on the Geochemistry channel live. We'll do it live, but no nucleotides. I can't talk this morning. It's too early.
And what we are talking is very nerdy, so no
I
worries.
know. Oh my
Okay.
God. All right, look. So Oscar, he's got 11 years of experience in environmental and mineral systems. He specializes in geochemical monitoring, numerical modeling of water, gas, rock interactions, and mine closure evaluations. He has developed advanced tools for remote monitoring, mine drainage analysis, and geochemical characterization, combining his expertise in programming with hands-on fieldwork. His work spans multidisciplinary projects across diverse and challenging environments worldwide, including volcanic and mining regions in South America, Oceania, and the Caribbean. Oscar, I think this is a fairly decent summary of your professional life that I got from LinkedIn. But having worked with you now for a short while on a project, I think it's going to be more fair for you to narrate your own journey. Could you tell us about your experience through the mining and environmental geochemistry industries? Perhaps sprinkle some advice in there for our listeners who are excited about environmental geochemistry.
I can do that, but before that, just let me tell you that I didn't start my career as a environmental geochemist. As I was telling you before, I started my career doing some geothermal exploration. I finalized my pre-grad geology studies in Chile in 2010,
Which university?
Universidad de Chile,
Okay, obviously. Okay.
the
But I
best
have to
one.
know the best one.
Yeah,
Yes,
the
yes, yes.
best one ever.
But if you're a little bit alternative with your music and stuff, I don't know, you could have been somewhere else. So I don't
My
know.
music. Okay, I just listen metal and rock.
Okay,
It's
actually,
not
that's
so
very Chilean.
alternative.
Yeah, that's actually, yeah,
And
alternative for
cumbia,
here.
and
But
Chilean cumbia as well. Yeah.
oh God, okay, continue.
Okay. And then even before finalizing my pre-grad, I started my PhD in same university, but and my PhD was about volcanic, active volcanic and geothermal system. Actually, I started doing gas and water monitoring on different volcanoes and geothermal system in Chile and
I love
Italy.
that. Oh my God.
Yeah, I was one of those crazy guys entering inside the crater of of volcanoes.
Have
And
you read my economic geology paper? That's what I did for my master's. Oh
actually,
my, we're the
uh,
same, Oscar.
yeah,
We're the
imagine
same.
that we
Yeah.
this meeting, this interview was fated
Faded.
from the very beginning.
It was
Yeah, so as I was telling you, I was one of those guys entering inside craters, taking gas
I love that.
from jet
Yep.
funerals, gas sample from jet funerals, taking water sample from
Yeah,
crater
yeah.
lakes.
Sure.
Yeah, it was great.
Any notable volcanoes that we would know or just like obscure?
Yeah, yeah, Etna,
Oh, okay. So not just Chilean. You went to, okay. So we went to Etna. Where else did we go?
volcano, volcano.
Okay. Yeah, yeah, yeah.
Yeah, I went a bunch of volcanoes on Napoli and Sicily.
Wicked. Okay.
The Aeolian volcanic islands.
Yes.
Yeah, those are little islands inside, so in front of the Sicily
Mm-hmm.
island. Yeah, I went there as well. And I did a 6 month pasantee in Italy during my PhD studies.
Um.
And I started approaching to the environmental geochemistry world when I was in the second year of my PhD.
Mm-hmm.
My wife, Javiera Mulet, she's also a geochemist, a very well-known geochemist,
Have her on the
actually.
show.
Yeah,
Yeah.
exactly.
Yeah.
You will have to interview her.
Yeah. The
Uh,
more Chileans, the better. I haven't interviewed a Chilean in way too long. Okay, continue. We're getting too excited and off track here.
she got a scholarship to do her master
Mm-hmm.
in New Zealand, and she wanted to
Okay.
do some studies on environmental geochemistry.
Okay.
Actually. So after our Italy advent, we came back to Chile, and a month later, we traveled to New Zealand,
Mm-hmm.
and I finalized my PhD from there. Most of my field were done, so I need just to wrap up my thesis and finalize the all the papers I wrote. So yeah, my supervisor was okay with it, and I have the chance also of visiting the White Island in New Zealand
Ah, the Holy
just before
Grail.
the explosion.
I'm gonna have Stuart Simmons on the show in
Really
in a few months. Or actually I think later
nice.
this month. And oh my god, I got so distracted. Anyway, we were all about the White Island. We're talking about Giggenbach. I don't know how the interview's gonna go, but it's just like all the things. And I'm like, oh my god. Yeah.
Yeah, I
If
still
people could see our hand motions right now, they're for me, they're very New York Italian. For him, they're like all over the place, excited, Chile. Yeah.
it's great. Yeah, I know Stuart. I've been in a couple of courses with him. Yeah, yeah, great. Yeah, everything is connected. The geochemist
Everything's
world
connected. Yeah.
is very small.
So small.
So for those listening this interview, you should be aware that every step that you do in this little world, it's going to be known by someone.
Yeah, and also I would say too to people listening, I met Oscar now, what, maybe a year and a half, 2 years ago? Not even. It couldn't
No,
have
one
even
year
been
and a
that.
half.
Yeah, okay, so year and a
Yeah.
half. And we're working on a mutual project together at this one mine site, and we just got a little bit to chatting, and now we're best friends because we have so much in common. So that's the thing too.
Well,
You just don't know how many people that you know in common, and it just makes friendships deeper. And now he's moving back to Chile. I'm going to go and visit. We're going to go to the family farm, drink some wine. I think, Oscar, how many friends do we know in common that you have?
You have worked with a couple of my,
That's what I'm saying. It must be
yeah,
3 or
my
4.
university classmate
That's
actually.
what I'm saying. It's
Yeah,
bizarre, but it's not.
but
Anyway.
it's not. It is just
Yeah.
telling that how small is the world. That's
Yes.
it. Even if we study in different universities, and
Yeah.
we
I
are
was in
now working
Canada.
in different fields.
You were in
Yeah,
Chile.
yeah,
Opposite sides.
yeah. It is sick. So basically,
Yeah.
living in New Zealand,
Living the life. I love it.
visiting this amazing geothermal field. I
Mm.
got my first job there as a geothermal exploration geologist,
Yeah. Okay.
and it was amazing. One of the best jobs I have had, especially because I didn't have kids at the moment because I travel a lot. I visit the Caribbean island, like three of them: Saint Lucia,
Oh,
Grenada,
I know Montserrat's a big one.
Dominique.
The
I stay in amazing resorts. I visit this island in Africa, the Comore Islands. I applied different geophysics method to put it and wrap it with my geochem methods and geology exploration just to find out where the resources were, the temperature of the supposed resource. No, yeah, it was amazing. It was
I
crazy.
think this is something actually I want to take a little sidebar and say to people. I've noticed that with a lot of the younger people that I work with that they're very hesitant to do things a little bit crazy and move abroad for work. And I have to say, I've never had a better time in my own career than when I lived abroad working. So, guys, you're young. You got nothing tied. Don't just work in your jobs near the hometown. Now's the time to do some crazy things. And this sounds so fun. Continue. Sorry,
It is the
had
way
to do
you
it.
learn, actually.
Yeah.
Imagine I was doing some volcanic and geothermal monitoring on my PhD, and 1 year later, I was right away applying those methods in different volcanoes and different geothermal systems around the
Oh,
world.
so cool.
And everything that I learned on my PhD was being on use for geothermal exploration.
That's so
It was
cool.
crazy. It was crazy. I learned so much from other Chilean guy, Luis
Mm,
Ursua. He was living in New Zealand for, I don't know, 10 years before me. And he did his master's over there. And he taught me a lot of stuff as well. And that's the first also job I was able to start applying some satellite monitoring techniques to
okay.
define the extension of the geothermal system, finding the alteration mineral association, things like that, mapping structures, the typical things that you do using your satellite image. And yeah, that was my life until 2016 when we moved back to Santiago from New Zealand. And I couldn't find a job in geothermal in Chile.
Mhm.
Although Chile maybe will have the greatest geothermal capacity of
Oh, I
most
bet.
countries in the
Yeah.
globe, we just have one geothermal field
Interesting.
producing electricity in the north of Chile.
That's
Estadio is
because you
run.
guys are just so busy enjoying swimming in them that you don't want to.
Nah, it's more. It is more complicated than that. But for the sake of this podcast, let's say that we enjoy the geothermal areas for recreational purposes only.
Oh, but Tatio. Okay, but that's a
Yeah,
famous
but El Tatio,
field.
yeah, in the
Yeah.
north of Chile.
Let's
And
go on another little journey here. If people don't know, where is Tatio? Why is it so famous?
El Tatio is one of those geyser type of places
Mhm.
around the world. There are a few of them, like Yellowstone for North American ones. And El Tatio, the eccentricity of El Tatio is that this is a geyser located at almost 4,000 meters of
Yeah.
elevation,
Super.
super high, and it's beautiful. Just the whole context where you are is just beautiful. And El Tatio historically was the first geothermal field after Larderello in Italy to be explored to produce electricity. Actually, the Italians that arrived after the First World to the north of Chile, they started to explore this place, but it never happens because it
Mm.
is too far away from the nearby city. But I think that 5 years ago or 6 years ago, this Italian electrical company, they built this geothermal field and now is producing electricity, finally, after 100 years
Yeah.
of exploration. It is the
Fascinating.
first geothermal place producing electricity in South America. I couldn't
Anyway,
find a
guys.
job. I
Yeah.
couldn't find a job there.
Find a job. Meanwhile,
uh, yeah,
2016, I was full on living in Chile. We could have known each other, but we didn't. But we could have been at the same barbecues, but we
yeah.
wouldn't have known.
I don't know. Yeah, that's crazy.
It's wild.
Maybe
Yeah.
you met my wife because the girls that you know,
Mm,
they are very close friends of my wife.
who
So
knows?
yeah, maybe you cross path at some point in a party because
Guys, you got to
South
be
America
careful. You got to be
parties.
careful. Yeah. It's not a party. It's an
eh,
asado. It's a barbecue. Yeah.
nice.
Anyway, continue.
So that's when I jump in the to the environmentalist world. That's the moment I started working for a Spanish consultancy company called Anfos 21.
Oh, I know them. Okay.
And yeah, and that's when I remember my first day at work, just knowing nothing about environmental geochemistry. And the first, what I did that first day was reading all the previous report
Mm.
that all the geochemists wrote. And I realized that, oh, so this is an environmental geochemist. So you do some rock characterization, you collect water samples, you analyze the inorganic chemistry. Oh, I know this. I did a PhD on this. So I realized that all the gas water rock interaction modeling that I used to do on at high temperatures can be applied for low temperatures as well. So that's how my career takes me to the point I am now, working in USA for SRK as an environmental geochemist, and has been great actually. I cannot complain. I'm doing a lot of interesting stuff as the one that you put in the article, monitoring mine drainage through satellite images, and it's just great. I think we can talk a little bit about that.
We're definitely going to talk. Our whole thing is about this. So
Yeah.
I can't wait. All right, cool. Do you have any advice for listeners that are interested in getting into environmental geochem?
Yes. If you really want to get a career on environmental geochem, one of the things that you need to be aware is that at the very early of your career, you need to go to the field. That's the most important part. And independent of the path you want to follow as a geochemist, just go to the field and apply your geology knowledge or your environmental knowledge, depending on your background. But go to the field and do field work. Learn how to collect water samples, learn how to collect rock samples, go to the lab, learn how to analyze the chemistry or the isotopic composition of your samples. Go to the mineralogical labs and learn the different techniques. That is the only way that you will actually learn what is behind the data you're analyzing. Because the work that we do as a geologist is analyzing data that has been collected historically by different companies and different people, of course. And when you try to analyze it all at once, it usually will have a lot of possible failures that if you haven't been in the field you won't realize what are those failures. If you want to analyze data, independent of the geology field, geochemical field that you're working on, you need to know how the data is being collected. And to do that, you need to go to the field, you need to go to the lab, you need to talk with the people compiling the information. You need to get your hands dirty.
Such good advice.
Yeah.
So with that, I want to thank you for sharing your journey with us. But now it's time for tea time. En otras palabras, ahora es el momento para todo el chisme. Okay?
Okay.
The kettle's hot. Spill.
Maybe the cheese is not a cheese, but you can find it on YouTube actually. It, it is about my first interview, the one that I
Okay.
told you in this
Well, I think
Comore
what's
Island.
beautiful about this is that you can tell it in how you see it, and then we can all go and watch it.
Oh, yes, exactly. And we can actually quote it in the comments.
I love
I can
that.
find that.
Yeah.
I can find that video and put it in,
Oh, amazing.
yeah, in the comments so you can see it.
Okay.
I was so nervous because the whole idea of the interview was, meanwhile, I was doing the field work itself. This journalist is going to be, or supposed to be, asking me questions about my work.
Where were you?
Yeah, yeah. In the Comore Islands.
Okay.
I was actually in the top of a volcano doing some CO2 monitoring, just to define where are the main structures. I was so nervous and also in a rush because my flight supposed to depart in, I don't know, maybe 5 hours. And I was trying to finalize the CO2 survey after 2 weeks of, and you can notice in the interview that I was very technical describing what I was doing. The guy didn't follow me. My English at that moment wasn't good at all. It was worse than this English that you're listening now.
I love this English. I love the accent. I love it all.
His accent was, these islands, they speak French, so his English was very difficult to follow as well.
Mm.
And I don't know, it is just a joke. Two guys talking about different stuff. He didn't follow what I was explaining him because I was very technical. I was in a rush, and I don't know, you have to see it. It is fun. My wife has been making fun of this interview for, I don't know, for a
10
while.
years.
So yeah,
15 years.
So you have to see it.
Okay. You have to see it to believe it.
Yeah,
I
see it
love
and
that.
like
Okay, so we'll then put maybe in the show notes, but definitely on YouTube, we'll put a link to this because the sounds
yeah. Hopefully
perfect.
nobody how do you say, how do you say when they get rid of the video?
Oh, nobody's like taking it down or something.
Yeah, taking it down.
Okay.
I'm gonna try to find it out. If not,
Okay.
I'm pretty sure that I have a record and I can put it on light again.
Okay.
I don't know if I want to do that, but
I feel
have
like
to.
I feel like you
Yeah,
have to now. We're
yeah,
too
kind
far
of.
in.
Yeah,
I think it's funny just because the way that Oscar presents himself now in like meetings and everything is just, while still very technical, it's so professional, but it's also very good at communicating very in the weeds advanced topics at a level that everybody in the room can understand. And if you're in a room where you're making decisions at like a mine site, say, you have your technical team, but you also have your engineers who know nothing. But then you also will have people that just do planning and stuff like that. So people that don't have any kind of background. So it's funny, I think, just knowing Oscar now and just knowing how he will present these complex topics in a way that we all are just like, oh, okay, cool. I get that. I get why we need this, or etc. And so I would love to see him talking English, not knowing English, with somebody who's French that doesn't really know English. I don't know. I like it.
no, yeah, and for some reason the whole interview was about like a general explanation of the field work that I was doing there. And I
Yeah.
was so focused on explaining him how the soil CO2 surveys was about, how the CO2 is getting analyzed, what the curves that I was getting on my tablet at the moment means. Yeah, I don't know why. Yeah, it was so stupid. Yeah, but think that that type of things can happen. So
I
and
think
you will learn from it,
at the
especially
same
when
time,
you
I
see
think
it.
I'll share a link in the show comments on YouTube with when I was doing my second year of fieldwork. We did something, I wasn't in it at all, but my two professors, they were helping out. I think it was also a French crew, but they were doing some kind of documentary on the Cowiichen volcano, which is renowned for being number one beautiful with its crater lake, just because it's so acidic and it's this beautiful blue. But there's also an active sulfur mining operation there, which people get paid nothing, and it's really sad and everything. Anyway, they were doing this whole thing, but they were explaining what they were doing scientifically, but because they were much older, the way that they broke it down was just so simple and accessible to people. Anyway, I'll put Journey of the Continents in the show notes so that people can compare the two. And you can learn for
No,
your next interview.
no, definitely. I had the chance of presenting at the Frixie conference last year in Washington,
Mm,
D.C.
yeah.
David Parker and Apello were there. It was a great congress and course, Frixie course. And you can notice this as well. The way that David Parker, specifically, the way that he teach people how to use Frixie is just phenomenal.
Mm.
The guy is just so simple. He's explaining very complicated topics, but the way that he explained it is amazing. So yeah, as you grow up and you interact with people, you're realizing that sometimes, depending on the public that you have, you need to try to be as simple as possible to explain complex topics. In some other places, you can explain yourself and explain complicated things in a complicated way as well, because
Mm.
not all the processes can be explained straightforward. But another advice would be try to simplify your explanation as possible as you can.
Yeah, definitely. Because I think the other thing too is that you're always having to sell yourself, right? In the sense that going back to say our meetings, you needed to make an acid rock drainage model. And for that, you needed to have sulfur, sulfide, carbon, inorganic carbon. You needed to have these extra things, which are an extra expense. So you needed to you needed to make a very complex topic much simpler for people so that you could be like, hey, I need you to pay this extra $20 a sample because we need to do this, etc. It's this skill set that is learned, but it's so important for your career because if we didn't get those extra add-ons, you couldn't make this. And then people at the end of the day would be like, hey, how come we don't have this model? And you'd be like, I tried. And like, that's not good enough. So,
Yeah, that's a key thing. When you need to, especially when you're working, you need to be simple but as accurate as possible of the things that you need to carry out your work. And if this is not available, I will not be able to finalize my work. But you need to explain that. People sometimes, no, you cannot just assume that people know the whole pipeline that you have for finalizing your work. So yeah, you need to be as clear as possible when you are working.
for this episode, Oscar knew immediately that he wanted to talk about using Google Earth Engine, Python, and mine drainage. So, can you talk a bit about what you mean by this and why you're so passionate about it?
And I know that
So
word,
passionate. Yeah.
yeah, that word describe the sensation I been experiencing with Google Earth Engine. And I feel like every time that I do this quote, I come back to my early days of work because I discovered Google Earth Engine maybe in 2015 through
Oh,
a
I didn't
paper.
know that.
Yeah, through
Okay.
a paper that was released in USA's about monitoring crater lakes
Okay.
and the relationship between the color of the water and the activity of a volcano. I can't remember which volcano was it, but yeah,
Cascadia,
there is
maybe
yeah maybe
somewhere out there.
and I'm not sure if the listeners knows what is Google Earth Engine. If not, you are more than welcome to start using it. I'm not a Google Earth seller, so you don't need to pay me any fee, you know, of this. But I will just tell you that Google Earth Engine is an amazing platform that has several thousand satellite images. For example, all the Landsat collection from the fourth early 70s to the Landsat 9, the most recent one. So for all the world, all the Sentinel-2 repository, the Sentinel-1, the Sentinel-3, climate change models. What the platform does is that through Java scripting or Python scripting, you can select whatever data you need, satellite type of images or georeferenced data from whatever place around the world. So you can build your own time series about a specific area. And yeah, so you can actually do for the very first time using Google Earth Engine, planetary scale analysis of whatever can be monitoring through from satellites.
Yeah, I find when I was using it between that and QGIS, that's for me the only two ways that you can open source effectively you use remote sensing. Otherwise, you really have to pay for it. And I found Google Earth Engine to be I didn't know how to code Java or Python before, and I think I tried it out using Python. But now with ChatGPT and everything, you could do it even easier, figuring out the different call codes and everything. But it's honestly not hard. And it was really cool to be able to look at areas of interest for me for exploration. So whether you're doing environmental exploration, whatever, it's something open source and really accessible. And I also really liked it. I'm
No,
not as
no, it's
passionate, but you're
no, it is just amazing. I'm working with a student now that because I really like to do research as well. That's part of the PhD path I took at some point in my life. And I'm working with this student to use the color, the real color of the water, the hue color, to monitoring changes in the physical chemical characteristics of peat lakes. And we are applying this method in the very well-known Berkeley peat lake in Montana. You know that this pit lake has been there for almost 40 years, early 80s. It has now a pH of 4, but it had a pH of around 2 when it started. Now this pit lake has a depth of 100 meters. Sorry, I don't think it fits. So
I like
don't ask
meters
me the
better. Yeah.
conversions. Yeah, about the conversions. So what we're doing is using Google Earth Engine. We are with all the Landsat and Sentinel-2 series. You can actually map where the water body is, the area of the whole water body. And once it's mapped, you can take and estimate the color of that water, and the color of that water can give you indication of the different state of the pit lake and how its physical chemical characteristics have evolved in time. The theory behind this is not just a qualitative comparison, this is a quantitative comparison because the color of the water, especially in mine drainage related bodies, is given by the pH, the redox, the concentration of iron, the concentration of copper, and the concentration of aluminum. These 5 parameters will just, it will give you a general idea of the color of the water that you're expecting. So if you map the color of the water, you can infer how these 5 parameters have evolved in time. And it's just great. We are hoping to publish this research this year. maybe later this year. He's finalizing his thesis now. So we're going to start writing the paper as soon as he finalizes the thesis. And hopefully people will start using the method because it's just amazing
Love
how
it.
just through the color of the water you can infer the physical chemical characteristic of the water itself.
That's so neat. Let's take a step back though, just to talk about some of the foundations of this work, which is remote sensing and spectral data. So, for our listeners who are maybe new to this, could you explain first what NDWI is and how it leverages water's spectral signature to
Yeah.
do this identification and mapping of water bodies?
Yeah. The acronym that you just mentioned is basically normalized water index. I'm not sure if the listener will know about satellite
Go for it.
images. You have two types, active and passive. The active ones are those satellites that sends radar signals to the surface of the Earth. And what the satellite does is calculating the time difference between uh, the signal that he sends and the signal that he's receiving. Those are the typical radars, and those radar satellite can be used for many purposes, but from a geological perspective, they can be used to monitor subsidence and heave of the terrain because of different type of processes. For example, in environmental geology, you will use it to monitor the stability of tailings, the
Yeah,
physical stability of tailings.
this is a really cool application.
Yeah,
Mm-hmm.
stability of the pit walls as
Mm-hmm.
well, how the heat paths are behaving as well. Yeah, there are many applications. And also you have the other family are the passive sensors, which use the light of the sun, the light of the sun that is getting reflected from the surface, and they are catching that. So the satellite can catch that reflected light, and the light has also different wavelengths, of course. And the satellite can catch different wavelengths that will give you the spectral, how do you say this? Spectral, the type of the spectral that you can catch. For example, Santal, the Landsat 4 catch the light in just four sensors: the
Mm-hmm.
blue, the red, the green, and the short infrared red. And now the most recent Landsat one catch the light at least in 9 bands or 10 bands,
Yeah. So,
expanding all the spectral region that they can catch the light. And the whole idea of these passive sensors, and because these are the ones that you can use to map the different things from the land surface, is that, for example, each thing that is in the surface of the terrain has its own spectral signature. And what is the spectral signature? The spectral signature is the light that is not being absorbed by the body, is the one that is getting reflected. For example, the water itself like to catch the light in the short infrared wavelengths. So what you will, how do you map the water from satellite images? You will try to find bodies where or whose infrared intensity is very low in comparison to longer wavelengths like blue or green. So that's basically how you construct the normalized water index and how you map water bodies using this technique.
that's interesting too. Just a sidebar thinking about atmospheric windows, that it's, which is just to say that because there's water in your atmosphere and other things like carbon dioxide, etc., those are just regions of the electromagnetic spectrum that you don't actually see. But it's cool that there's this workaround where you can actually be mapping these water bodies, which is then essential for this research.
And this technique is not just being used in the Earth as a planet. It's the same technique that you use to map mineral deposit in Mars or in the moon. Where is water? Where is not? How much iron free is can be observed or which type of mineral alteration have you observed in other planets. Yeah, it is the same method that you can be applied here in the Earth planet or in other planets as well.
So miners, environmental geochemists, were not so different from space scientists, which is cool.
Which is amazing. I'm not sure if you have been receiving this LinkedIn alert about actually real jobs of planetary geochemists. There are consultancy services now that being offered to, I don't know, maybe SpaceX. I don't know who is leading the whole
Mm,
exploration, but you can apply geochemical exploration methods
for
to
sure.
exploring ores in in planet Earth, but in other planets now, and people are paying for that, and the jobs are very well paid.
I'm gonna write this down.
Yeah,
I'm always looking
definitely.
for a side hustle. I love that.
And you can even go to Mars for an
I'm
exploration
okay.
campaign.
Yeah, I'm
And
okay to not go to Mars. This is not a dream of mine, but to do it, yeah, I could apply what I do. Why not? Okay.
yeah,
All right.
and
We're filing that
you
away.
yeah, exactly. You can go to the field. However, it's gonna be a
That's what I'm
one
saying.
way field.
Like, I can't bring my cats with me, so I'm not interested, but
No, it is crazy.
yeah. All right. So, something else that's really interesting is that I found about reading through some of the work is that you're using some physics informed machine learning in your workflows. So, could
Yeah,
you explain what this means in practical terms and how it enhances your ability to map these dynamic processes?
yeah. Even though these normalized water index were the difference between a long and short wavelength should give you an idea of what is water and what is not. The chemical characteristic of the water can produce changes in the absorbance of the light itself. So in practice, this means that when you work with just a single image, you can define a threshold where the normalized water index will give you and map clearly the area of a water body. However, when you use this method in a time series, for example, as you can do it on Google Earth Engine, you cannot just apply one specific threshold because the water body will change in space, in time as well. And the chemistry of the water body will change as well. So that's why you need these machine learning processes to start doing these dynamic mappings of what's water and what's not. And by dynamic mapping, the mapping by using all the Landsat and Sentinel images available for a specific region.
Yeah.
And what this machine learning technique does is basically trying to figure out by their own learning from previous experience what is water and what is not, but not just using the normalized water index, using the whole data available in satellite images, in a single satellite images or in a collection of satellite images. And this is amazing because it saves you a lot of time and is quite precise. And the way that I apply the things, I usually apply the normalized water index method for the whole collection. Then I just see the results, and you can classify results in terms of successful and unsuccessful based on the normalized water index method. And the successful one are then grouped together and pass as training cases automatically. So the algorithm can use it for recognize pattern using all the bands available in each of the images within a collection. And once that algorithm is trained, I applied the whole algorithm for the whole collection. And that's crazy because, for example, in the case of the Berkeley Pit Lake, the normalized water index yelled as around 40% of the successful cases. images where that technique can map properly what is water and what is not. But after applying this machine learning technique, we increases the successful cases from 40 to around 90.
Wow.
Which is amazing because as you have more images available for mapping the color of the water, you have more data to compare against the water chemistry itself, which
That's
is
so
great.
interesting. It's cool too because once you have devised and thought up of the code and the way that you're going to do it, which I'm sure took quite a hefty chunk of time, but then it just everything becomes just so rapid. So now you can just apply this technique. You start at Berkeley, presumably now you can apply this technique to a pit in southern Arizona, in Mexico, wherever.
Yeah, actually, what the second phase of the first part of the thesis was take one of the most well-known pit lake with public available data, the Berkeley one, to present the method itself. The idea is that the people trust in the thing, but the second part of the work is applying this method and map all the pit lakes in Chile. And once we have done that, we're gonna start using it to map the pit lakes around the globe. That's the whole idea.
That's so cool.
Yeah. So hopefully in the short term, you're gonna start seeing this paper published. And that's another thing, Matt, that maybe our younger listeners would like to know. When you're actually working and not doing and not being part of a university itself, that doesn't mean that you cannot do research. Actually, I think that is there is a great chance of doing research when you are working for private companies as well, because when you are working for private companies, you have access to information that university researchers do not have, and also you have access to problematics that people from the universities are not exposed to. Example, all the mine drainage kind of things are quite restricted in terms of information because mining companies do not want a lot of attention to their mine related issues. So if you start doing some research, you can see that most of their researches in Spain, Canada, USA, Chile, Australia, New Zealand have been done in places or publicly well-known public places. But if you want to start digging a little bit more in private places, there is little information about it. As a consultant or working for private companies also open you the appetite of, come on, we can do some more research about it. There is a need of doing more research, and it's great.
That's such an interesting point and
Yeah,
a really interesting plug for people getting out of universities and not doing 8 postdocs, but rather just working in industry.
and you will see that most of the mining companies are willing to publish their data, especially when you are proposing a serious research, something that will make them jump and make their life easier. For example, having this technique of monitoring pit lakes from a satellite perspective just open a huge new capacity of not going to the field to collect these samples from pits, especially abandoned pits where all the slopes can be a little bit dangerous just to get pits because of physical risks and things like that. They're willing to support this kind of research. And sometimes the people from the university perspective, they since they do not interact too much with clients as consultants do, it is you just have another perspective of the needs of mining companies.
I agree with that. I haven't done quite so much research, but I found in some of your other points there that I've found very similar things with the mining companies.
But you
Um,
have done some research, Sam.
I have.
Yeah. You know how to use all the data collected from cores, especially this hyperspectral data. I'm pretty sure that few people
Yeah,
know
I
how
mean,
to manage that amount of data and
yeah. So
how to
from that,
use that type of data as well.
like, I guess, like for me, like that was more of an in-house. I had learned what I wanted to do from being a vendor, but then applying that and actually being able to put some of that stuff into practice. I only really started to get to do that consulting with people because it was their data on the line. They wanted models or they wanted this, that, or whatever from it. And now I'm looking to work with some people. There's a special issue coming out in GEA in August, I want to say. So I'm working with a few different people to get some things published. Okay, so maybe I do a little
Yeah,
research.
of course. Because that's the
There we
thing that
go.
I'm telling you. The
Yeah.
the research that you do is not just about publishing data that it doesn't belong to you, because that's not my point. Is creating techniques of crossing data like geochem data, hyperspectral data, geological current. The only way of creating those techniques is because you have been exposed to that type of work. And that type of work is not something that you will learn in the university itself. It's something that you will learn in your work career.
Yeah, definitely. And you
Yeah.
can't, as much as you want to as well, you can't ever plan like how your work career is going to go. I would never have said that I'd be in Chile, I'd be working for a vendor, I'd be doing this, that, or whatever. It's just you can't plan these kinds of things. You can only take the opportunity as it presents itself and make the most out of it. Okay. So let's move on then. Something that I was interested in, some of this material that you passed over was talking about processes like sulfide oxidation. So, what I was thinking of, in addition to water bodies, you're also looking at quantifying changes in these, as we've been chatting about, these physicochemical conditions or characteristics of mine water and of sulfide oxidation rates in mine waste deposits. So, how do these different mapping tools help in these efforts?
Nice. Very good question.
Woo!
Oh, are you a geologist?
I
Nice.
am. It's
Oh,
shocking.
yeah, it's shocking. Yeah.
Shock.
You know that you will, especially younger folks, as you start working, you're going to start reading different AIs documents or environmental documents, different consultants trying to explain loadings. And you will find the word loadings everywhere in environmental geochemist documents. And by loadings, how much mass is being released, mass of different elements are being released from the rock to the water body. The whole idea of mine, and one of the main goals of this particular work, is to explain how waste deposits, mining waste deposits, impact the water quality of the surrounding water media. And to do that, there are different techniques. One of the most used and well-known method is that you test this waste in the lab. I don't like this approach, it's quite engineer. So I prefer a more scientific approach rather than an engineer one. But the whole idea is that you quantify through, or you expose this waste to weathering, chemical weathering, just by applying water and pouring water to this water sample and calculating the composition of that water sample. Once the composition is measured in milligrams per liter, since you know how much water you use it and the mass of your waste material, you can then calculate that composition, transform that composition into loadings, which means how much milligrams of each of the elements are being released from a certain mass of waste. And if you know the mass of that waste in the field, then you can have an idea of how much mass of elements that particular deposit will be released to the nearby water bodies on time. And the whole idea of using satellite images is to put some more information in this plate to make the calculations. As you can map water from the space, you can also map minerals associations as well. And this is something that is a technique that is quite common when you're doing exploration, when you're mapping cores. But I'm using this technique to estimate how the intensity of iron 2 minerals are decreasing on time, but also how the intensity of iron 3 minerals are increasing on time. So these two curves on time will give you an idea of the oxidation rates. Oxidation rates given by the oxidation of sulfurs like pyrite, which is the most common sulfur that you can find in sulfurs related mineral deposit, and is the one that pays my salary because it's the one that produce acidic conditions on time, which is, and this is great. This is something that I have never seen before in any paper. But if you, for example, I applied this method in a tailing deposit, and every time that you measure through different satellite images on time the same pixel, you could notice how the intensity of the iron 3 minerals were increasing on time, and the intensity of the iron 2 were decreasing on time. And the changes between, and the time changes, for example, you know that since each satellite images has its date, the date that were taken, you can actually calculate rates of changes. And those rates of changes are surprisingly very well related with the rates that you can measure in the lab using these kinetic tests that I just told you at the very beginning. And it's amazing because it gives you an idea where the oxidation rate is occurring and at which rate is occurring. This is another thing that I try to convince my client to publish. Something that is not has not been developed before, and give you an overview, amazing way of monitoring your waste deposit from space. And you can also do some management to prevent acid rock drainage in these specific places. For example, if you know that a specific parcel of tailing area of tailing is the one that is getting oxidized more rather the other places, and you know that if that specific parcel interacts with water, most of those oxidation products are going to get solubilized and released to the environment. You can go there and put some chemicals additives in that specific parcel just to prevent that beforehand, before the interaction with waters occurs.
So are we essentially talking now also about how we could prevent and or remediate acid mine drainage?
Exactly. That's the whole idea of using open source satellite images, because everybody can monitor these kind of things. And as you have more eyes on things, people are going to start remediating things more.
And I think this is so cool too, because I think a lot of times we just focus on sulfides, but essentially we're now talking about focusing on sulfates, iron, oxyhydroxides as well. And so we're simultaneously through satellite imagery having a look at all of these things and monitoring all of these things.
On time and in space.
It's all clicking now. I think I had 5 questions around this, but I'm just like, no, it's all not that it's all the same, but what you have dreamt up with your colleague is it's looking at all of it at the same time, which is beautiful.
Yeah. Yeah. And if you cross this information with radar information, you can also create a beautiful dashboard of your mind, because radar, as I told you before, will give you an idea whether the terrain suffer any subsidence or heat. Waste rock piles, when you are constructing a waste rock pile, what you will check from using radar is that specific parcels or specific areas of your waste rock are gonna start giving you an increasing signature of the terrain. So you can map where on time are you depositing your waste materials on time. With the passive sensors, you can map what type of material has been deposited and what is the oxidation rates of sulfides of that specific parcel before receiving another load of weights on the top. In the same time, you can be monitoring the chemistry of your surrounding water bodies, the superficial ones, of course. So you can create a beautiful dashboard using just satellite images on how your mine site is changing. And with all that information, you cross it with all the water samples that you're collecting, superficial and groundwater,
Yeah.
and you will notice that there is an amazing spatial correlation of where your loadings are going, which are the water receptors that are receiving those loadings, and what type of measure you can take to prevent the release of those loadings into the surrounding water bodies.
That's so cool.
Yeah, that's my dream.
I guess it's just I've seen this in pieces, right? And I would also say it's not done enough in our industry right now to use
No,
either satellites or lidar to be mapping subsidence in your mines. Like you can see slope failures, you can see all the things. So that needs to be much more widespread than it currently is because we can also prevent up to mortality basically in these things. But it's just something that's already not being done. But you're talking about not only including this piece, but then also layering on top with just some beautiful geochemistry. I couldn't be more thrilled using remote sensing. You're just integrating all
yeah,
parts of this
that's the
podcast. I
whole
just love
idea.
it.
Is that yeah? The whole idea is that you have. Uh, I'm thinking this as a forensic type of analysis. So every time that you do some numerical modeling work, there is a lot of uncertainties in the different assumptions that you make to estimate loadings, to estimate how the water quality will change on time. What I'm saying is that we have, I don't know, for example, if you count the number of satellite images in a site that has been open from early 80s, nowadays you will have from open source images satellite at least 1,000 images available from early 80s to nowadays from a specific site around the globe.
That's
That's
incredible.
the number of at least the number of data that are going to be available. Of course, you will need to QC and select the ones that are not cloud cover and things like that. But at least you will have 1,000 satellite images to start working with. And those satellite images will give you a broad idea of what's had been going on in that specific site. How many waste rock dams has been built? How many pits has been built or excavated? Whether you have a heat leach pad or not, whether you have a tailing deposit or not. What are the possible surface water bodies that are receiving these possible loadings? How the vegetation have changed in the surroundings. Yeah, it's been so unused. So what I'm here for, I
This is
want to
my
develop
mission.
this methodology to start using or make use of this data to do or work as a environmental geochemist.
I
Yeah.
think then let's just end off on just something that's a little bit forward looking, which is do you see any advancements in satellite technology such as NMAP, the hyperspectral satellite, or Pixel? Do you see any advancements in machine learning technology that you think will significantly improve the accuracy of mapping mine drainage and water bodies and other things that you're interested in?
I'm pretty sure that as we move forward in time, the open source datasets that are going
Mm,
to be released are gonna give us a better spectral, time, and spatial resolutions
yeah.
from the ones that are publicly available now. You have to take account that Sentinel-2, the collection, is the one with the best spectral and spatial resolution. The Landsat collection is the one that has best time resolution on time. And then you have a lot of private sensors that will give you a spatial resolution of centimetric spatial resolution in comparison to Sentinel-2 that has 10-meter resolution per pixel and Landsat 30-meter per pixel. Yeah, as these sensors becomes available, we will have better data to work with, a more accurate estimation of the processes that we want to estimate.
I love that. Yeah, all these new sensors coming out. I guess then it's just you have the benefit of Sentinel and Landsat just being time wise that they have data back since the early 80s. Yeah. Oh, no, I love it.
No, which is amazing. And I'm not sure if you have done it, but you will have to try to interview the people that has been discovering mineral deposit through satellite images, especially the ones that were discovered in the 90s using the Landsat 4 and Landsat 5
If you have some
collections.
names, I'm happy to hunt people down.
Yeah, it's impressive because the resolution of those sensors were very shitty, but were amazing for the time.
Mm,
But if you see the images, you will realize that how can you work with this? But there were a lot of geologists that they use this sensor to discover deposits, and it's amazing.
yeah.
Amazing.
Look, I just want to say thank you so much for being here. And I hope that you enjoyed talking about your vision on the show as much as I really liked hearing about it.
No,
I want to thank everybody for listening to GeoChemistry and a big thanks to Oscar Benavente for being on the show, dishing some chisme, and talking about mine drainage, satellites, remediation, and all of the innovation that he and his partner are up to. So I want to thank our sponsor, LKI Consulting, and to It's Water and Coma Media for our music. And I'm looking forward to chatting with everybody next month.
thank you for inviting me. Yeah, this was a chat. Thank you.
Yeah, maybe your best interview yet.
Hopefully, my wife's not gonna make fun of this interview.